Hey class, Absolute 5 here. So today we're going to be talking about continuity. Now, what does continuity mean? Well, it just simply means that a function is continuous, meaning it just goes on forever and ever and ever and ever and ever, kind of like how time is constantly going forward and it's continuous because nothing can really stop time. So what why should we care about something that is continuous or continuity? Well, let's see what that means. What does it mean for the definition for something that for a function to be continuous? So the definition is a function f is continuous on an interval if it is continuous at every number in the interval. So what does that mean? So when you really think about it, let's say I have -1 and 1 as an interval example. There are infinitely many numbers between -1 and 1. 0.3, 0.4, 0.5, negative of those same numbers. So there's so many points. That's why we say when something is continuous on an interval, you could take any interval or any number and it has to be continuous at every single point within that interval or just about any point on the real number line. Now, here are some conditions that need to be met so that something is continuous. So f of a is defined. What does that mean? That letter A has to be within the domain. So that means that little element, that little point has to exist within your function or within your machine. And that the limit of f of x exists, that it has to exist, otherwise it's not continuous at that point or at wherever it is. And that the limit of a of f of x equals f of a. That means if you plug the element a into that function, you should get an output with that element out. So that means these are the three conditions that you need to be met for something to be continuous. The element has to be within your domain. Your limit has to exist to begin with. And 3, once you put it in, you should get something that matches your function when you put that function in. So pretty much think of it like this, that you put a quarter in the vending machine, it should spit out a candy bar. If you put a quarter in the vending machine and if it spits, and if it explodes or something, then that's a problem, obviously. Then that means it's not continuous. So that means something's in error. So let's give an example what a continuous function looks like, or what it is one that meets the definition. So let's see. A continuous function. So we'll take one simple example that I like to use a lot, which is the limit as x approaches 2 of x squared. So we already know what x squared is, right? It's a parabola. It's continuous and smooth, and it just shoots up everywhere, and it's at 0. So it's smooth, everything works. That's why when I plug the limit for this element in here, this is my element A, I plug it in here. Oh, one more thing. This is my element A. It's definitely within this, 2 is within the real number system and it won't affect the function at all. The limit definitely exists for this function, because when I take the limit of this function, I get 2 squared, which is just 4, and that's the output. So it's like when you put your element in your machine, it does exist and it will spit out something for you. Now let's get a counterexample. What does it mean if what happens? Let's say what happens when you put the quarter in the vending machine and it blows up. What do we call that? Well, F is defined near A. We say F is discontinuous at A if F, put a dot, if F is not continuous at A. So that means there's a malfunction within your function, that was tongue twister, that something's wrong when you plug this element into your machine and that for some reason it doesn't work. This is just a long way of saying that when you plug your element in your machine, it just doesn't work. That means it's discontinuous at that one point. Therefore, it's not continuous. So let's give an example of something that is discontinuous. And the very nice simple one would be, let's see, what would that be? This example, f of x, and it's going to look like this, curly face bracket, 1 over x squared if x is not equal to 0, and it's 1 if x is equal to 0. So now what's the problem with this situation? We can already know we're going to have a problem at 0, so let's get right into that. If f of 0 is 1 is defined, meaning if it does exist, but we have an issue. If we actually take the limit as x approaches 0 with our function, specifically the top part, we take the limit as x approaches 0, 1 over x squared. What's the problem with if we plug in 0 here? This function becomes undefined, and we already know whenever we have a 0 in the denominator, it becomes undefined. That means this function's limit does not even exist. Therefore, f is discontinuous at 0. So this shows you that not every function is going to be continuous. Not every function is going to be nice and simple, but this is good to know when something's smooth, going on forever. That means it's continuous and it works for a lot of good reasons. Now, when it's something that's discontinuous, that's going to be a problem, that's going to be an issue, and that there's always going to be limits within that limit, if you understand what I mean. When I say limits, I mean there's only so much you can do with that function before you reach that point of exhaustion. When you hit that little 0, specifically for this one, it just won't work at all. So that's the lesson for you guys today. This has been Absolute 5. Be sure to like, share, and subscribe to this channel. If you like the content I'm producing, leave a comment below. Let me have any suggestions to make it better. Let me know. And also hit the bell button besides the subscribe button so you guys can get more content of mathematics, which I know you guys love. And I will see you guys tomorrow for another video. So this has been Absolute 5. I'm Roger Palomino. And math is infinite because math is infinite because there are infinitely many possibilities. Have an absolutely lovely day.